We'll wait for a few minutes for others to join. All right, let us start. Maybe others will join with time. Welcome everyone to the week 1 tutorial for the course IC engine and gas turbine. Okay. So my name is Varnit Kapoor and I will be taking up this tutorial for this course. So I hope I'm audible right now to everyone. Can anyone unmute and speak? Am I audible to everyone?
Yes, sir.
Oh, great. All right. Okay.
Yes, sir.
So, okay, thank you. All right. So before starting, I think I'm not visible right now. Visible. Yeah, great. Hi. So may I know that the strength of this batch is particularly of, I hope it will be of the UG undergraduates. But may I know, like, are you in your first, second, third, which year, or you are from which university? Maybe anyone is from NITs or IITs, central universities. I hope everyone is a UG. Okay, great. Okay, Suraj, you are from which university? You raise your hand.
Sir, NIT or not Pradesh?
Okay, great. Okay. Anyone from state universities? I just want to have a mix that from where all of the students are. Shashwat. Okay, great. All right. So I hope everyone must has watched the week 1 lecture videos by the professor on the NPTEL portal. I expect that. Probably the assignment also might have been floated by now, which is required to be submitted within the time. So let me start with the first tutorial. And again, I'll brief myself that I'm Varnit Kapoor and I'm from IIT Delhi. I'm pursuing my PhD here. All right, let me start. Let me share my screen first. I hope my screen is visible. Okay. All right. So I'll be just briefing with the concepts, with the tutorials that what has been covered so far. If you have any doubts at any point of time, please don't hesitate to stop me and ask. You can unmute yourself or raise your hand, whatever is suitable for you. Okay. And we'll start with the IC engine first. When we'll cover up with the IC engine's concept, then we'll start with the gas turbine part. Okay. And yeah, so let us start. Please feel to ask doubts. I like that if someone is having any questions, I can answer. With that, everyone learns, me as well. Okay. So I hope whatever I'll be writing here, IC engines. Okay. And I expect that everyone should be like regular to their assignments. This is how you will learn very in a very better way. Okay. Okay. So what is an IC engine? As the name suggests, if we see what is an IC engine. So IC engine is, anyone can tell what is the IC engine? What they understand by an IC engine? Yes, Shanmugam, you have unmuted. Yeah.
Sir, the combustion is inside the cylinder. That is
Mhm.
called as IC engine. The
Okay.
combustion
Yes.
is take place inside
Correct.
the cylinder.
Yes. So internal combustion engine, where the combustion is taking place inside the system. Okay. Inside the cylinders. Okay. We have a piston cylinder arrangement generally. So inside the cylinder. Okay. Internal combustion engine is the full form. Yeah. Correct. So IC engine is nothing but a device where the heat engine generates a mechanical power by burning the fuel, whatever fuel you have, like a gasoline or a diesel, inside a combustion chamber. And this combustion chamber is an integral part of the working fluid circuit. Okay. So what we do, we convert the chemical energy of the fuel into a thermal energy, and that thermal energy is converted into a mechanical energy to drive the vehicles or generators or whatever the device is. Okay. So let me write first of all. I'll write each and every definition. You can also write side by side. I'll upload these notes, don't worry. And you will get a sheet from the NPTEL team where the PDF of all these notes will be available to all of you. As well as this lecture is also being recorded. So you can also, I'll upload this lecture on every tutorial which I record. I upload it on my YouTube channel as well. Okay. And the name of the YouTube channel also I'll write towards the end. Okay. Although it is NPTEL with Varnit, but I'll write in the PDF as well towards the end of the site. But I request you that you should all be regular to the tutorials as well to listen with a live interaction one-on-one, whatever doubts you have. Okay. So I was writing, oh, okay. An IC engine, an internal combustion engine. I hope whatever I'm writing is visible. Anyone can confirm me?
Yes, sir, it is visible.
Okay. An IC engine is a heat engine that generates mechanical power by burning the fuel, which can be gasoline or diesel. So gasoline is generally a term for petrol. Okay. In the West, generally they use a term gasoline instead of a petrol inside a combustion chamber. Okay. And this combustion chamber is a which is a an integral part of the working fluid. Okay. Working fluid circuit. Okay. Next point is that it converts chemical energy into chemical energy into thermal energy by burning the fuel. So the calorific value of the fuel is burned by converting into a thermal energy, and then into mechanical energy. Someone has joined. Okay. Then into mechanical energy. Okay. Which is typically used for driving the vehicles, typically powering the vehicles, or generators, or you can say industrial machinery. Okay. Okay. All right. Now let me just give you a science of how the petrol engine basically works. Okay. Let us first go with the petrol engine, then we'll come to the diesel engine. So let me write petrol engine. Introduction. So there is a piston cylinder device which is connected with a, everyone has seen this kind of geometry or actual vehicle everyone has seen in our day-to-day life, where we have piston cylinder arrangement. There is a spark plug inside that vehicle. There is an inlet, there is an outlet from which the air fuel mixture enters and the exhaust gases went out. Okay. So we have a geometry like, let me first make it. Let me make a some, maybe I'm not making it a better one. Okay. So we have a inlet valve, we have an exhaust valve. Okay. I'm just making a schematic diagram. And we have a device that is a spark plug. I'll explain that why this spark plug looked like this only. What is the science behind that? But just bear with me. We have a piston. This is a piston. We have, okay. We have a piston then which is connected to a connecting rod. Okay. Right. Use this. That is connected to a crank rod, and that crank rod is connected to your shaft. Okay, crankshaft. All right. So we have a top dead center. This is called as TDC, that is your top dead center. And we have a bottom dead center from where your piston moves. Okay, from top dead center to bottom dead center. Okay. Initially, what is happening? This schematic notation, this means that the valve is open. If I want to draw a notation like to close a valve, what I'll make, it will be like this. Okay, the valve is closed. So exhaust valve is closed, whereas the inlet valve is open. So what happens initially, you draw a fresh air fuel mixture at a atmospheric pressure inside the piston cylinder arrangement. Okay, so what you do, here we have a fresh air fuel mixture, fresh AFM. AFM stands for air fuel mixture at atmospheric pressure, at P atmosphere. Okay, because you have ambient pressure and the air fuel mixture enter into it. And during this, what will be the pressure inside the cylinder? For any fluid to flow from one position to another, there should be a pressure gradient. A pressure difference should be there. Okay. So if I am saying that air fuel mixture is entering into the cylinder, piston cylinder arrangement at an atmospheric pressure, then automatically it means that pressure inside the cylinder will be less than the atmosphere. Then only a fluid can flow in that scenario. Okay. So that means your pressure inside the cylinder is much less than P atmospheres. Okay, then only a fuel can enter. Okay. So this is your suction stroke. When the air fuel mixture enters and the suction is being created and it draws such that the piston moves downward. Okay. So this is your suction stroke. Let me write, this is connecting rod. This is your crank rod. Someone is trying to join. Okay. This is your crankshaft. From where the power is transmitted to the wheels of the vehicle. Okay. This is your crankshaft. And this pole is your suction stroke. So let me write here. This is your suction. Okay. This is your first stroke. You try to enter the air fuel mixture. I'll go very slow so that you understand once how the cycle works. Then we will draw the graphs, pressure, volume, temperature, entropy, all of these graphs we will make. Okay. But first, basic understanding how a petrol engine works should be in your mind. And this is your spark plug. Okay. So these are your devices in a piston cylinder arrangement. This is your suction stroke. So pressure in the cylinder is at this position is, pressure in the cylinder at this position is equal to P atmosphere. But above, that means above the piston head, the pressure is equal to P atmosphere, whereas below the piston head, the pressure inside cylinder is much less than P atmosphere. Okay, you are creating a suction inside it. And how this suction actually works in your vehicle, when you just start your vehicle, what do? you turn on your key. Because of that, there is an electronic system which is there. A motor try to activate and it tries to pull for the first initial stroke, which is happening, suction. That means it is trying to pull it down because of the pressure difference creates and air fuel mixture enters inside that. Okay. So what happened? The piston has, so I'll make this is your piston. So piston basically moved from an inlet valve is open. Make sure exhaust valve is closed, whereas inlet valve is open during the suction process. You don't want that whatever enter should immediately leave. You want that during the suction only fuel should enter, it should not leave immediately. Okay, that's why it is closed. I'll write that also. Exhaust valve, inlet valve. Okay, IV and EV. Okay. Now, as soon as we have all the air fuel mixture have entered, now your piston has moved down. Now your piston has moved down till bottom dead center. Okay, from top dead center to bottom dead center, and you have a complete air fuel mixture inside it. Okay, and your walls are like this. So now both of your valves will close. Both of your valves will close now because you have entrapped whole of the air fuel mixture, and air fuel mixture was entered inside the piston cylinder at atmospheric pressure. So when whole of the cylinder is filled with air fuel mixture, that means your cylinder pressure will be atmospheric pressure. Okay, so this air fuel mixture, AFM, air fuel mixture, is at P atmosphere. P atmosphere. Okay. From top dead center to bottom dead center. TDC to not here, sorry. I'll tell you that why TDC is here, not at this position. I'll tell you that also. Don't worry. Let's go one by one. From TDC to PDC. Okay. So now suction stroke has completed. Okay. In this scenario. So suction stroke has completed. Put it here. Okay. This was the suction stroke. Let me write point but 2. Let's draw the, I think till here it is clear how the suction stroke has happened. Anyone has any doubts in suction stroke? Please ask me if you have any doubts. I want that this working should be very clear. Based on this, every cycle will work. Any doubts to anyone? Yes, Santosh. You can unmute yourself and pressure will, as I've said that it will be less than the atmospheric pressure. Pressure above the cylinder piston will be equal to atmosphere. So there is a pressure difference because of which the fluid is trying to enter. Okay. Any other doubt? For the initial start, you start with your key, the battery system. But when it starts running, then this is what I'm explaining. When the system has achieved a steady state, when you have started your vehicle and what is happening. Okay. So this is your suction stroke. The piston has moved from top dead center to a bottom dead center, and whole of the cylinder is filled with air fuel mixture at a atmospheric pressure. Okay. Now what happens? This will move again up due to the inertia. Okay. So now what happens? Third figure, let me draw. Now your piston will move from bottom dead center to top dead center. From bottom dead center to top dead center. What is compression ratio? I'll tell, don't worry. We'll come to all of these things. Compression ratio, everything. Don't worry. Okay. And this was your spark plug. Okay. And this is your compression stroke. Compression. So your piston has moved now from bottom to top, from bottom to top. Okay, from bottom to top. So what happened? It was filled with initially full air fuel mixture. When you are compressing a air fuel mixture, so that air fuel mixture will finally fill the space like this. Okay, the whole air fuel mixture has been compressed. But petrol has, when you are dealing with a petrol engine, petrol has an ignition temperature a very higher than the compression. When you have compressed a gas or a mixture of gas with the fuel, air is your gas and you have mixed it with the fuel. Although if you increase the pressure, eventually the temperature will also increase. Okay, but still the ignition temperature of the air fuel mixture is less compared to whatever compression you have achieved. Okay, that's why your spark plug is needed, where it provide a slight spark. Okay, if you have seen in your common household how you can visualize a spark plug is like, you have a gas stove mechanism in your kitchens. Okay, you have a lighter, everyone has a lighter there. You just press the lighter, you see a small spark. Okay, you see a small spark coming out of it. Similarly, a spark plug works here as well. That's also a spark plug from which your gas stove, the flame burns. Okay, so similarly you can experience or visualize like here that when you have compressed the air fuel mixture, at that point of time the spark plug is in the activation and that creates a spark. And now because the spark has been generated, the temperature in the cylinder has achieved a higher temperature. The spark temperature is higher than the ignition temperature of the air fuel mixture. So what will happen? The fuel will immediately burn. The fuel will immediately burn. Okay. So here, if you see the pressure inside the cylinder, obviously is much greater than atmospheric pressure because you have compressed. Okay, in the compression stroke, you have compressed the air fuel mixture and the pressure has reached much higher. So because of that, temperature inside the cylinder, is much greater than the flash temperature, T flash. Okay, T flash temperature of the combustion, from where the combustion can begin of the air fuel mixture. Okay, and as soon as you provide a spark, if you provide a spark, this is a notation in a red dots, a spark has been provided. That means you have provided the heat has been added, heat addition. So I expect that everyone has gone through a basic thermodynamics. So heat is adding, and heat is adding. If you can think that at the same piston cylinder scenario, at this position itself, at a particular instant, heat is added. So that means the volume of the cylinder is currently is constant. Currently, the volume is maintained constant. So heat is added. This is a process that is, in thermodynamics, we say that heat is added as constant volume. So this is heat addition at constant volume. Okay. So I'll write like this: heat addition at, in subscript, at constant volume. The volume is maintained at a particular instant and heat is added at that same instant. Okay. So heat addition at a constant volume. So if you have seen an equation, that is your dq is equal to du plus dw. Okay. From laws of thermodynamics, if you see, your net heat interaction is nothing but sum of internal energy plus work done. So if I'm saying that heat is added at a constant volume, what is a work formula for the work at for a volume at a constant volume? General work done is nothing but PdV, pressure into change in volume. So this is basically PdV. Okay, and when I'm saying that heat is added at constant volume, then dV will be zero at that instant. It will be zero. Why? Since volume is constant. Volume is constant. That means your heat interaction, net heat interaction, is nothing but equal to net change in the internal energy of the system. And what is the internal energy of the system? That is CV dt. dq is nothing but CV dt. Okay. Okay, dq is nothing but cv dt. So that means your internal energy is only a function of temperature. So heat is only a function of temperature currently. That is why I explained mathematically also and physically also that because of the pressure increase, the temperature will increase. Why the temperature increase? Because on adding the heat, the dt also changed. Okay, from the first law of thermodynamics. All right. So that's why I said you should have a brief idea about what happens in thermodynamics. Okay. So here you have added the heat at constant volume. So when you add a heat, the fuel will burn automatically. That's what you see in the gas stove mechanism also. As soon as you press the lighter on the gas stove, immediately the gas flame comes out of your stove. Okay. And you can cook your food. So now, because a sudden high pressure temperature scenario has been generated, what will this piston do? This will automatically go down. This piston will go down. So let me make it in a different figure. Fourth figure. So this piston will immediately go towards the bottom dead center. Okay, from top dead center. From top dead center to bottom dead center. So that means this is nothing but your power stroke. You are getting a power out of the engine, and it is a very high power generator. Okay, and all these things, both the valves are closed. Since after the suction, all the valves will be remaining closed. So I'll make these valves also, because you don't want right now that your air fuel mixture should go out. Okay, till power stroke, all your, yes. Can you share as PDF? This, let me again tell you all that the PDF of these notes will be shared. All these lectures are also being recorded, and these will be uploaded on my YouTube channel as well. Okay, as well as the NPTEL team will share the PDF of the link and the lecture videos. The name of my YouTube channel is NPTEL with Varnit. I have already taught 3 courses so far on NPTEL. You can check those courses as well, but let's focus on this course currently. All these recordings, notes, everything you will get, and even in the video description also on the YouTube, you will see the link of the Google Drive for the notes. Don't worry about that. All the material you will get. Okay. So now what has happened? Your piston has moved from top dead center to bottom dead center. Okay. And then it carries a very high pressure temperature scenario because a flame has been ignited. So I'll make a down arrows with red color. That signifies that your pressure inside the cylinder is very, very high. Okay. And this is around, you can say, 75 times or 100 times higher than the atmospheric pressure. You can imagine what can the pressure can be. I'm just giving you a glimpse. Okay. So pressure inside this scenario is nothing but very, very high than the atmospheric pressure. Okay. So what we can say that, and this is your nothing but expansion. This was your compression. This stroke was your compression. Let me write it here. Okay. And this will be your expansion. Or you can say power stroke. Okay. This is your expansion or power stroke. Okay. So what you have done basically, your heat is nothing but your low grade form of energy. Heat is always a low grade form of energy, and you have converted into a work. You have, how you have converted? You have displaced some piston. You have displaced a piston with some displacement and applying the force. So this heat, that is your low grade form of energy, is converted into a high grade form of energy. And that you get from your qualitative law of the thermodynamics, that is second law of thermodynamics. Okay. So low grade heat is converted into high grade energy, that is your work. Okay. So I'll write all these points. That's why I'm writing here. So low grade form of energy is converted into high grade form of energy, that is nothing but your work. And work is nothing but your pressure inside the cylinder, which can be around 100 or 70 atmosphere. Okay. 75 bars. Okay. So pressure inside the cylinder is into displacement, or you can say delta V, sorry, change in the volume. Okay. work done is nothing but pressure into dV. What that is only I wrote PdV. Okay, pressure in the cylinder and the change in the volume from top dead center to bottom dead center. This is not a rectangle. This is a cylinder. You have a cylinder, so you visualize this like this. Okay, so here your valves are there. Your spark plug is here. Okay, your piston is like this. That has moved from this to this scenario. Okay, so imagine like that. So pressure into cylinder into volume. And what is change in volume? That is nothing but force into change in displacement. Okay. That is F delta X. Because it's a closed system device. That's why I'm writing PdV. If it would have been an open system device, it will be VdP, negative of VdP. You might have studied in the thermodynamics. Okay. So we are done with the compression stroke. We are done with the expansion stroke. So what we have done so far is that we sucked the air fuel mixture. Initially, the cylinder pressure was less than the atmosphere. That was because of the pressure difference. The air fuel mixture came inside. The piston moved from top dead center to bottom dead center. Then whole of the cylinder was having air fuel mixture at a constant pressure. That was atmospheric pressure. Then the compression started because of the inertia of the system. The piston moved above initially, and the compression increased the cylinder pressure, but not enough. So that's why I provided a spark heat through a heat addition at a constant volume through a spark plug. The air fuel mixture burnt, and then the piston moved from a top dead center to a bottom dead center with a very high energy. That's why it is called as a expansion or power stroke. Is it clear till here, or any doubts that how you get a low grade form of energy? That is your heat is converted to high grade form. Any doubts to anyone? Please ask. Feel free to ask.
So the
Yes.
combustion which is taking place during the compression cycle will always take place between the TDC and the engine
Yes.
cylinder head only.
Yes, inside the cylinder only. Exactly. That's why it is internal combustion engine. You can have an
Okay. No,
external
no,
combustion engine. Those are yes.
I was just asking that the combustion which is taking place is in the within the TDC and the engine head only. That the
Yes.
clearance
Yes.
volume.
Yes. This. Yeah. I'll come to that point. Clearance volume quickly. Yes, definitely. Inside this, the combustion will start. Exactly.
Okay, sir. Okay, sir. Thanks.
So imagine like this now that again you come to your gas stove. Okay. It is not like that. The when you just spark the uh, lighter, it's not like that. The flames come out at your face, right? It is in a confined volume. Okay. Similar happens like this here as well. Okay. All right. So, any other doubts? Anyone else? Now again, the system has an inertia. Okay. So this piston will now move above. Okay. So let us see the next scenario. What happens? That is nothing but your exhaust. Okay. So till now, all the valves were closed. All inlet and exit valve were closed. You got the power stroke. But now one of the valve will open. That is your exhaust valve. Now your piston is here at this scenario currently. Okay, at BDC, bottom dead center. And this is your TDC. Okay, your spark plug. Then I have my inlet valve that will remain closed, but my exhaust valve will open at that instant itself. Because when you ignite something, combustion happens, it will carry some exhaust gases as well whenever you burn a fuel. Okay, some gases will also be coming out of it. So this is nothing but your expansion stroke. Me right? Expansion, or you can say exhaust. Okay, and here the exhaust gases will be coming out of the exhaust valve. Okay, and as soon as it comes out, it will achieve atmospheric pressure because it has been inside. It was a higher pressure during the exhaust. Let me write here. although pressure during exhaust was greater than P atmosphere, eventually your pressure still after combustion also you achieve a power stroke. Your pressure is still high, although it was here 75 bars, but when it reached here, it will be still higher, 2 bars, 3 bars, whatever it can have. Okay, so pressure in the exhaust is greater than the pressure atmosphere, or you can say pressure in the cylinder. Okay. That's why the gases come out, and as soon as they come out, they will achieve atmosphere because they have been uh, thrown out in the atmosphere. Okay, so what is happening? The gases have some heat. Okay, the gases are not cold gases. They have been burnt. The fuel has been burnt and achieved a very high temperature. So whatever exhaust gas will come out, it has some heat entrapped in it. So at this instant itself, at this instant, when it is at bottom dead center itself, almost 90% of the gases have been exhausted. Still 10% will remain. But what you observe that the gas carry heat, and that is a low grade form of energy. And at that instant itself, the heat is being rejected out of the system, at constant volume again. Okay, because it is, I'm talking at that instant itself. So here the volume will be remaining constant. Okay, burning temperature you can check on the, I don't remember the exact value, on internet you can see what is the flash temperature or ignition temperature. Okay, so we have a difference in the ignition temperature or flash temperature as well. Okay, that I'll come to the later part of the IC engines. Don't worry about that thing. So what I was saying, yeah, so 90% of the gases have been escaped out. Let me write 90% plus minus, you can write exhaust has been escaped out, and here the heat has been rejected at constant volume. Heat rejection at constant volume. Heat rejection. Yes, yes. Okay. So I was saying that heat rejection is constant volume because at this instant itself, when the piston is at the bottom dead center, 90% of the gases have been came out of the, because at that instant itself the exhaust valve will open. Okay, so because of that, 90% of your gases carry forward outside at an atmospheric pressure, and that means your gas are carrying some heat because the fuel has been burnt, and that low grade form of heat is carrying some low grade form of heat has been carried outside with the exhaust gases. And at that instant itself, when the volume the piston was at BDC, the volume of the cylinder was constant. That is why I'm saying that heat is rejected at the constant volume. Heat is rejected at the constant volume. And rest remaining 10% which are there, I again make, so this was fifth, this was sixth. Okay. So my piston has now moved, you can say, to again to top dead center from bottom dead center. Okay. Okay, and this is your exhaust stroke because it carries the inertia as well. Because of the inertia, the piston is moving to the top dead center from the bottom dead center after your power stroke. So finally we can say that remaining 10% and the valve will still remain open. The exhaust valve remain open, whereas the inlet valve will remain closed. Okay, you don't want that fresh air filled mixture also enters and exhaust out. That's why I'm saying. Okay, so that is a leakage of your fuel, which you don't want. So remaining 10% of the gases go out. This is your spark plug. 10% exhaust. Okay. So this was your exhaust stroke. All right. Any doubts? So this was your complete cycle. So what happened? Your first stroke was suction stroke, where your piston moved from top dead center to bottom dead center. Okay. This was a suction stroke. Oh, sorry. Top dead center to bottom dead center. Then your compression stroke happened, where the piston moved from bottom dead center to top dead center, where you added the heat at constant volume. Then the third stroke was an expansion or power stroke, where the power has been generated, and the piston move from top dead center to bottom dead center. Finally, the exhaust stroke, where the piston move from where all of your gases exhaust out from bottom dead center to the top dead center. So that means we have 4 strokes with us. Okay, suction stroke, compression stroke, power stroke, and exhaust stroke. 4 strokes. So this is a 4-stroke cylinder device. Okay, I see 4-stroke device. That's why we say that it's a 4-stroke engine. Okay, that's the reason we say that it's a 4-stroke engine. Any doubts there? Please ask. I want you to ask me if you have any doubts. You take about a minute. I'll give a short 2 minutes break. Think about it. Okay, and then I'll join back. And if you have any doubts, please ask. I'm keeping it like this only. In 2 minutes, I'll be back. Okay, all right. I'm back. Yes. Any doubts to anyone? Please ask. Then I'll move forward. How do a spark plug knows when to spark? So that's a timing. Through a time chain, earlier engine, now we have electronic circuits. So that can be controlled. Uh, expansion stroke once. Expansion stroke. I think I cleared one. So expansion stroke, the cylinder is moving from bottom dead center to top dead center. And at that instant itself, 90% of the gas, exhaust gas come out. Okay. And it is like taken out into the ambient or atmosphere. So that means, and these gases are at a high temperature. That means you are rejecting a heat at constant volume. Any other doubts? All right. So now let's understand about the spark plug. So one point one student mentioned that there was a clearance volume, that combustion is happening inside the between clearance volume and the above the piston. So why I am making a top dead center not here but here with some gap. So there is basically a, will any of the port will open in that time? Which time? Which time you are saying? I've made all the figures. During exhaust, yes, definitely. Obviously, expansion, you want your gases to come out. So your expansion valve should be open. That's why I made an open sign. Okay. Eventually, yeah. So I was saying about the clearance volume. So exactly why we maintain the top dead center a bit lower than the head of the cylinder. So the reason is that first, if you can see that if your piston will go till above this, it will hit the spark plug. You don't want that. Spark plug is just inside the piston cylinder. Okay. Also, it will hit your inlet and exhaust valves. Okay. So you don't want your valves, or because piston is having a very high pressure and that impact is very huge. It will damage your other components, that is your valves and your spark. Okay. That's why you just keep a small amount of clearance valve. That is a very low volume, so that it should not hit. Okay. Okay. Next, I was telling, let's write some note points. Let's talk about the spark plug. I said no, I'll explain why the spark plug is made like this. So if you see, I have made a spark plug like this, okay, with some gap, which is not closed. So what is happening? You are providing a very high voltage at this point. So voltage is nothing but 10,000, around 10,000 volts, even much higher than that as well. So I'll write a plus sign. Okay. So you have a very high current and high voltage at this scenario. Okay. Because spark plug don't have any, you say, a fuel. Okay. So even join. Okay. So you are providing very high temperature, high voltage or electric current through battery of your vehicle. Okay. So very high voltage has been for a fraction of second, not for a long duration, just for a fraction of second. So what is happening? You have a plus sign, positive charge. Okay. Flow of electrons basically happens. So electron go from negative to positive and current flows from positive to negative. We have all understood in 12th physics. Okay. So current flow from positive to negative and electron flow from negative to positive. Okay. So if you see, this is your negatively charged. So what is happening? The current is trying to flow. Okay. Current is trying to flow, or you can say electron is trying to flow. But what it sees that there is a gap. This gap is nothing but your air gap. This is a air. Actually, there is an ambient condition. Air is there. Ambient air is there. And ambient air is nothing but a very high resistance. It carries very high resistance. Air it's a very bad insulator. It doesn't carry the electrons. But the gap is maintained in such a way that the electron is, that's why we are maintaining a very high potential. And that high potential is allowing the electron to jump from this state to this state. And this gap is not very like in meters or not even 1 centimeter. It's like very small in mm. So this allow a flow of electron from this position to this position. And when the flow is happening at such a high resistance, because air has a very high resistance, it doesn't allow the electrons to flow. Okay. If it would have allowed, we might all be having a experiencing current in the air wherever we would have sit. That's why we don't feel a current in the air. Okay. So at such high potential, the electron is flowing. Okay. There is a spark gap, which we say that this is your spark gap. Because of which, as the electrons, multiples of electrons are transferring at that same instant, thousand millions of electrons, that creates a spark. That is basically your spark. And here the temperature is around, you can say 1600 Celsius for a fraction of nanosecond or millisecond. Okay. 1600 degrees Celsius plus temperature is maintained almost. And because of that, you see a spark. You might have seen in the transformers of your locality, or even you see a lighter again when we come to a basic lighter. You see that the center rod and the outer frame, the spark travel from one position to another to the outer frame. And that is a very instantaneously happening. Okay. There you have a kerosene or something which you press, and then because of that, you provide a pressure through your thumb, and that gasoline ignites and that creates a spark. But here we have a high voltage from the battery. Okay, that's why spark forms. So it's basically a spark gap is having a high air resistance. Okay, so spark is being generated eventually. Spark is being generated, and when because of the flow of the electron. Okay, because of the flow of this electron. at a very high resistance. And now the question can come, how much, if we can increase this gap more and more, we will have a very high spark. But it has been tested that the graph for spark gap, if I make, let me write this here. So if you plot spark gap in the x-axis with spark strength, with certain amount, the spark with the spark gap, the spark strength increases. But after reaching a maxima, the spark strength decreases. Okay. So you can say that with increasing the spark gap, you can achieve a higher spark strength, but after that it will deteriorate. So there is a limit to that you can apply a spark gap, sorry, to achieve a spark strength. And these spark plugs are made from very high temperature, like bearing material. That is nothing but your nickel alloys, or you can say platinum. Okay. So high-end vehicles, very high-end manufacturing companies will have a platinum inside that, whereas cost economical benefit organizations will use nickel alloys. Okay. So these are basically your super alloys, which can handle such high temperature and voltage scenarios. So this is made of nothing but nickel or platinum PT alloys. Okay. Yeah. I can write platinum or nickel alloys. Platinum, or you can say nickel alloys. Okay. And these are nothing but your super alloys. Okay. Any doubts? Yes. Batteries of 12 volt and spark supply of 10. So there are the transformers which provide. That's why you see a small transformer if you see a circuit, 10,000 plus volts. Those can amplify. That's not an issue. Step up, step down transformers are there. Yes. Any other doubt? I'll not go into the electrical scenarios, but it can be achieved with the coil windings. Those things we have studied in our 12th, 11th basics. Any other doubts, please? No doubts? I think this is clear that why spark plug is made like this. There is a spark gap. Okay. So I'll write about the expansion stroke. Most of students are having expansion stroke doubt. So I'll write it as a note, second point. Okay. So from the figure number 5, I've mentioned the figure numbers. From figure number 5, after expansion, pressure inside the cylinder is much above P atmosphere. Okay. And also temperature is very high. Also temperature is very high. Okay. Due to this huge potential difference of pressure, due to this huge potential difference of pressure, almost 90% plus exhaust gases will escape out from cylinder, and this pressure process is known as process known as heat rejection at constant volume. Okay, heat rejection at constant volume. Okay, that volume is maintained constant at that position. Next, for spark plug also I'll write. Next point. For spark plug, for sparking, huge potential difference is required. Is required, which is generally can be greater than 10,000 plus volts. Okay, to overcome the air resistance. Okay, which is present in spark gap. Okay, and with the change of gap, next point, with change of spark gap, spark strength will vary. Hence, to overcome this problem, spark plug is made of nickel alloys as expansion, coefficient of thermal expansion of nickel alloy is 0, near about 0. So if there is summers or winters, this will not expand on its own, even if the vehicle is not used as well. Okay, so we don't want our spark gap to change automatically on its own as well. We are manufacturing a vehicle at a constant spark gap to be maintained with some tolerance value eventually. But and for that we need such a material that you can say that coefficient of thermal expansion of that material should be nearly to 0. It should not expand on its own. Okay, is made of nickel alloys as coefficient of thermal expansion alpha is nearly 0. Okay, all right, any doubts till here? We have done this complete 4-stroke cycle along with the spark plug understanding. Any doubts? Please ask. Because now we'll move to the individual components of the IC engines, like connecting rod, piston cylinder, piston ring will also be introduced, flywheel, crank rod, crankshaft. Any doubts, please ask. Am I audible to everyone? I am not here. Am I audible? Hello? Okay. So I think Kalyan, you should rejoin. I think so.
Sir,
Yes.
sir,
yes,
I
please
have one
ask.
doubt. Sir, what is
Yes.
the value of the spark gap value?
It's like in very millimeters. So I don't remember what are the exact values. Depends on manufacturer to manufacturer. So, but very in millimeters, if I can say. Okay. Yeah. Any other doubt? Hmm. For the auto expansion, okay. I'll come to the auto cycle later. Don't worry. I know people are much excited about that to come to the auto cycle, but we have to go step by step. Okay. Any other doubts? And then my next topic will be auto cycle only after the concept of these all the individual components. Any other doubts? Durga Prasant, are you there? Okay. All right. So someone was asking about the auto. Tennyson. Uh, is your name Tennyson or it's just your username you have kept like that? Okay. All right. Now let's come to the next topic, that is different component and geometry of IC engine. Okay. Let me draw the figure once again. Very clean figure I'll make this time. So if I say this is your top dead center, this is your bottom dead center. Okay. This is your spark plug. This is your exhaust valve. This is your inlet valve. Okay. Then we have the piston itself. Okay. And we have something called as piston ring inside it. Okay. And there is a pin which is here. Okay. In the piston, that is nothing but your gudgeon pin. It is called as gudgeon pin. Okay. This is connected via connecting rod. Okay. Connecting rod. Okay. Then there is a crank rod. This is your crank rod. This connecting rod is connected to a crank rod. Then there is a crank shaft which is eventually connected to. This is your crankshaft. Okay, and this crankshaft is connected to a flywheel for inertia. Inertia is stored in some device that is a flywheel is nothing but a inertia storing device. Okay, so I'll make it through another figure. So it looks like somewhat a big flywheel. Okay, so this is your geometry so far, and this crank rod is moving in a circular motion. So I can just make like this. Okay, so this crank rod moves in a circular motion as the piston cylinder device moves. Okay, so this is your gudgeon pin right here. Or you can say it is a piston pin, which connect piston and connecting rod. Okay, and these are water jackets. Because why water jackets? Your cylinder is at a very high temperature after the combustion of fuel. You want that cylinder to be, the heat should also be carried out. Otherwise, your cylinder will melt. You don't want that. That your whole system should fail and it should melt out. Okay? Because every material has some strength which it can sustain to. But after that, no, it cannot. And this was your flywheel. It is nothing but inertia, where the inertia is stored. Inertia stored. Or okay, so I think this is much visible, and if you will see the actual pistons, cylinder, gudgeon pin, you will see, you can observe this will look more or less like this only. Okay, so now let's talk about the gudgeon pin. So if you see that it is connecting the piston head to the connecting rod. Okay, so you can and experience that if someone is a gudgeon pin, if you sit on a gudgeon pin, the piston cylinder piston is moving at a very high speed, high revolutions. You say 1000 rpm, 4000 rpm, 5000 rpm a vehicle have. Okay, so you can understand that at per minute you are experiencing 5000 revolutions, 10,000 revolutions. So how much stress this pin is carrying with itself. Okay, if this pin breaks, your whole assembly breaks. So gudgeon pin is very important. Okay, because it is carrying very high stress scenario. Okay, from if you see from the connecting rod perspective, the connecting rod is pulling it, whereas if you see from the piston rod, it is pushing it downward. So you can see it is having experiencing a push-pull mechanism at the same instant. Okay, piston after the combustion is coming out downwards, it is pushing the gudgeon pin, whereas the connecting rod is moving downwards, it is pulling the gudgeon pin. So alternative cyclic loading is happening. Okay, so that's why your gudgeon pin is under a fatigue loading, complete cyclic loading or reversible loading. Okay, so that's why it is made up of very high strength material, that is your forged steel. Forged steel, and it is a ductile material. If you understand the ductile and brittle materials in your manufacturing subject. Okay, so forged steel is a very like high strength material. Basically what happens if you take, let me give you a glimpse. So you have a ductile piece of rod, small cylinder pin is like a small cylinder, like this pin is like something like this, small cylinder, which is between a piston. So here your cylinder and connecting rod is connected through this. Okay, so it's a pin is having very forged steel, so it's initially a ductile material. You drop or hammer it a very, if you have seen in your old movies or somewhere old videos, you might have seen that earlier the smiths used to hammer some of the steel or something. Okay, so that the strength of that sword or any device should be very high. So that means you are pressing it or dropping it so that all the defects in that inside the material, all the gaps or defects inside that material should go away, and that it should become a very high uh, strength product coming after being machined out. If you just machine it out also to remove some surface defects on that, like by brushing or whatever the scenarios are there in the uh, milling or rolling, and whatever the manufacturing processes are for machining. Okay, so we can say that it is a very high strength forged steel material for the Gudgeon pin. Okay, so our basic understanding is that why it is made up of very high strength forged steel, because it is undergoing very high cyclic loading, because piston is pushing, connecting rod is pulling, very high push pull scenario is happening. That is why connecting rod as well as your crankshaft or crank, you can say, that is your engine rod also. Okay, this crankshaft. Similarly, this crankshaft is also experiencing very high stress scenarios. So both are made up of very high force steel, or you can say drop forging is there. You will understand in your manufacturing subject or production subject what is a drop forging. Okay, it's a cold process. Okay, by hammering or by dropping it out. Okay, so let me write here about the connecting rod, or not connecting rod, sorry, Gudgeon pin. Or you can say piston pin. It is subjected to fatigue loading conditions that is nothing but completely cyclic loading or reversible, completely cyclic or reversible cyclic loading. If we say that, it should be made up of, hence should be made of forged steel, and it is ductile in nature. Ductile means the shape can change but the material won't break. Okay, like brittle. So we can write the point here is that connecting rod and crank also, connecting rod as well as crank is also made of forged steel, and especially by drop forging, and it is a cold drop forging, not hot. Okay, so what is happening if you have a connecting pin or Gudgeon pin? So in one cycle it is experiencing tension, stress is like tension stress. In another cycle is it experiencing compression stress. Okay, compression stress. Okay, if I make a graph of it, someone asks you how it will look like on a graphical scenario. So it will look like something like this. So this is tensile stress, and this is your compressive stress. Okay, so before forging, the stresses were very high experience. If I don't forge and just put the ductile Gudgeon pin, the forces will be very, stresses generated will be very high inside it. So stresses will be quite high, and it will experience a cyclic loading. But after you forge it out, after you forge it, the stresses experience will be this. And that's what you want actually. You don't want high stresses to be generated because it's always in a very high stress scenario. You don't want any internal stress should also be very high. Okay, so I'll write before forging. And this is after forging. Okay. So this is nothing but your fatigue loading condition or reversible cyclic loading condition, what I've written, where the crack propagation rate is infinite. If a small crack comes inside the pin, you can imagine that under very high stress scenarios, the crack will, a small crack, like if we say like a small crack generates here in the spin, if you see here, this can immediately damage the whole pin. And your whole engine piston cylinder arrangement will be damaged. Okay, so the crack propagation rate is very high here in the fatigue loading condition. This is your fatigue loading condition. So you can say that the crack propagation rate is nothing but infinite. Immediately the crack will propagate out. So you can say that your initially material was ductile, which was a steel alloy. Then what you did, you provided a forging, that is a drop forging, where internal defects almost were zero. Were almost zero. And finally, after machining, to remove surface defects. If you see any defects on the surface, you are achieving the very high strength, very high strength. I know it was a bit off towards the production side, but I have to explain that why gut joint pin has its relevance and importance. These questions comes. Okay. Any doubts? Now we'll come to a piston and cylinder. First was the gut joint pin. Next will be piston cylinder. Any doubts still here to anyone? So I'll take a short break of 2 to 3 minutes and then we will join back. Okay. Just be in the class. Okay, so we are back. So any doubts so far? To anyone, please ask.
Sir,
Yes.
sir, what is the work of flywheel in the system? What work does it
It
do?
stores the inertia basically. Okay. So when your piston is moving down, so at that time your kinetic energy is being stored inside the flywheel. And when you want the piston to move up for the compression stroke, okay, then this stored energy, potential energy is converted into the kinetic energy to move above.
Oh, okay, sir. Sir, so the
Give a
so
simple
the so
example
the
of yeah. Please ask.
so the purpose of flywheel is to create a reciprocating motion in a continuous manner.
Yes, you can say that.
Okay, okay, sir.
And you will study this flywheel in your theory of machines in a much better way. Vibrations and theory of machines subject. I hope everyone is from mechanical. Someone is from production or any other branch. So if you all are from mechanical, you will eventually see that. Give a simple example for inertia. Okay, very simple example. You are running. Okay, you are running and you immediately want to stop. Can you stop? Or you will take 1 or 2 seconds to stop? Santosh, you can unmute yourself and talk to me. And if you want to achieve suppose you start running and can you achieve directly a 10 meter per second of speed immediately? No. First, your body has inertia which was at rest. You started running from 1, 0, 1, 2 meter per second and achieve a 10 meter per second of speed. While you were running, your body was carrying uh, the energy which was stored in the form of a potential, and you were also running at that point of time. If I say immediately come to rest, achieve a zero velocity, can you? No. You have to, you will take few seconds, okay, to do that. So that means when a body, from the Newton's law also, when your body is at rest, it will remain at rest. When your body is moving, it will remain in the motion until unless any external force is applicable on that object. Okay. So that's why we want to store the energy somewhere so that, and eventually due to the presence of friction, you will stop afterwards. Even if you see a pendulum system, you drop a pendulum, it will achieve a motion, come to a steady state. After that, it will take few seconds to stop. Okay. Okay. All right. Yeah. There is one point I can just speak up that how you can make a ductile material to brittle is that by adding some silicon. If you add some silicon to it, okay, you can make a ductile material like stainless steel into a brittle material. Okay. Now let's come to a piston and cylinder, which I was saying. So piston and cylinder can be manufactured using cast iron or through a stainless steel or through aluminum alloys. Okay. So if we say cast iron in 90s, early 80s, 70s or 90s, you saw that very heavy loaded vehicles or cars. Okay. You used to see that. So their engines were made of very cast iron. Okay, very high, heavy. They carry very heavy inertia as well. Okay, and even if you are carrying a very high inertia or very heavy object, eventually it will, you can say, fuel consumption will be more. Okay, so I can write the first one is a cast iron. Cast iron. Okay, so these kind of engines. So if you want to start a piston cylinder arrangement of a cast iron, okay, these are very heavy, quite heavy. Okay, maximum in all of the above. Also, the inertia stored will be very high. Okay, is also maximum. And similarly, fuel, if something is consuming so much of inertia or very heavy to start, the fuel consumption will also be very high. So that is why if you see this average or mileage terms have come recently, okay, in our vehicles in late 90s or early 20s. Earlier they used to use this. They don't worry about whatever amount of fuel was used. So yeah, then stainless steel came. So other scenarios are like stainless steel. So if I go with stainless steel, their strength is a bit in the mediocre way. You can say that stainless steel is not that heavy. Okay, so you can say that strength is decreased as well as the life also decreases. Okay. And when I say that aluminum alloys, most of the manufacturers to cost cutting, if you see in the small hatchback cars, they use aluminum alloys for making the pistons and cylinders. I'll not take the name, but yeah. So they have a minimum strength. So if a car get crashed, whole of the engine is totally destroyed. Okay, because that's an aluminum alloy piston cylinder. But eventually, if it's a aluminum alloy, the cylinder, it's very lightweight. Fuel consumption will be less, but its drawback is that its strength and the life will be very less. Okay, so I can write that strength is minimum, life is minimum of all, but weight is also minimum, and fuel consumption is also minimum. So now you can say that why one of the Indian brand, I'll not take the name, but we can say that they manufacture a very high strength cars. Okay, even after the accidents also they sustain. So you can judge that it is a mix of stainless steel or cast iron kind of scenarios. That's why their engines are very strong and powerful. But eventually they'll take their mileage will also be less. Then the engineering comes into the role with that, how they're optimizing it. Aluminium can withstand high temperature or not. Aluminium can withstand. Obviously they can withstand. That's why we are using them as a cylinder, piston cylinder. With some coatings. So these are aluminum alloys, not aluminum, I'm not talking about the pure aluminum. Aluminum alloys mixed with something else. Okay. Next comes so we are done with the piston and cylinder. What kind of difference? Next is the piston ring. Very important. Okay. Piston ring. No, so far I have not told anything about piston ring here. Okay. But when I made this diagram, I made these two white lines. So these were your piston ring. So first thing is that on the piston, if you see, there are two small grooves, very light grooves, light thickness grooves. And if you have seen in a piston in a reality, you'll see there are rings inside those pistons, which are attached in the grooves. Okay. And these should be made up of cast iron, silicon cast iron. Okay. As I told that any ductile material can be converted into brittle by adding the silicon inside it. Okay. These should be specifically brittle and should have be and also be a smooth material. So silicon has a property, okay, that it provides a lubrication by itself. Okay. So you can say that the brittle material by adding it's a brittle material where the ductile material by adding silicon reduces the friction losses, makes it into a brittle scenario. Okay. Because if you see that why it is made brittle, a question can come. Suppose your piston is moving in a cylinder. So wear and tear is happening eventually. Whenever you are uh, like moving some device, friction is there, wear and tear will happen. Okay. But suppose that if it is a ductile material, then the piston ring will just bend or take some deform shape, but it will not break. Then how you will know inside the cylinder, piston cylinder or engine, how you will know that something is off or not. Okay. Because of this air fuel, piston rings are made brittle and they get damaged. If they are ductile in nature, you don't know that there is something happening. Because what will happen if they take some deformed shape, then air fuel mixture, which was in the suction stroke, was coming, that will go directly below the piston head, below the piston, okay, inside the cylinder, which you don't want. You want that whole of the initial during the suction stroke, your air fuel mixture should be above this head of the piston. You don't want below this head. Otherwise, it will not ignite during the compression stroke. Okay. And this kind of loss is called as blow-by loss. It's called as air, where the air fuel mixture has leaked out. It will not compress. It will go downstairs and uh, like settle down. Okay, which is not at all required. Which is a loss of eventually your fuel, and fuel is an economic resource which is quite expensive as well and limited in nature. Okay. So what is happening here? Air fuel mixture leaks, which is nothing but your blow by loss, called as blow by loss. So you want deliberately your piston ring should be brittle in material, so that when it breaks, you get a noise during the break, during when it breaks out. Okay, very loud noise it comes in the engine. Okay. And another thing is that how you can also detect if you are switched on your air conditioner in your car, suppose this fuel which has leaked and gone towards the bottom, this will not circulate, went out in all the other equipments of your engine. Okay. And you might have felt that sometimes from the air conditioner you are getting a fuel smell, because petrol has a very high, they forms very high vapors. Okay. Okay, vapor pressure is quite low. So you see that immediately the vapors, very high vapors are being formed, and you can smell those vapors from the air conditioner. And you get to know immediately that what is the issue in your engine is the piston ring have been damaged. And if the piston ring has damaged, then your wear and tear is also increasing very highly. Your air fuel mixture is getting leaked out. So for the detection of this, to reduce the blow by loss or air fuel mixture leakage, you want these piston rings to be especially brittle in nature. Okay, I'll write all these points. Then you will understand in a much better way. So let me write. It should be made up of silicon cast iron or silicon steel so that it will be brittle and smooth material. Okay, so brittle cast iron is brittle, I can say. Which is to prevent the blow by loss. Plus, if you add silicon in it, it provides smoothness. Smoothness is provided by silicon to reduce friction losses. So brittle is to reduce blow by loss, and smooth to reduce friction losses. So silicon is nothing but a carbon chain, and you know that layering of the carbon from the chemistry part. Self lubrication properties are there. Okay. Brittle because if it is ductile, then after some usage time, it will deform. The piston ring will deform and create a space. From where air fuel mixture leaks out of cylinder, which is not required. And this phenomenon is known as blow by loss, known as blow by loss. So if I say my piston ring look like this, and if it is in ductile in nature, if it is ductile, if I say it is ductile, okay, then what will happen? It is deformed after usage, and the air fuel mixture will leak out. AFM leaks out, and two piston rings are there. Deliberately, if one of the piston ring get damaged, in this scenario, two piston rings are there, both of these. Okay, even if one of the piston ring get damaged, you can change the other piston ring will still be remaining there to reduce friction and blow by loss. Because opening a engine is not a very easy thing all the time. Okay, so manufacturer take care of everything. Factor of safeties are already involved. Okay, so air fuel mixture leaks out. So what you do in this piston ring, you add some silicon balls. Okay, in this ductile material. So you add a piston ring like this. Some silicon balls are there. Okay, silicon balls. So that means you have made this into a brittle material. Brittle. Okay, brittle material. So what you can say that before combustion, if air fuel mixture leaks out, there will be some unburnt hydrocarbons which will eventually cause leakage, and it is harmful for the environment as well because it will create pollution. Okay, which is a primary source. And another scenario is that your like fuel is getting wasted out. Okay, and by adding these silicone balls, you are providing a solid lubrication. That is your continuous lubrication is happening. Okay, solid lubrication. Okay, that is your continuous lubrication. Okay. And minimum two rings are there. More than two rings are also can be there for very high speed engines. Okay, so minimum two rings are there. Minimum two rings. Okay, so that if there is a gap in one of them, another air fuel mixture leakage can be stopped. Okay, all right. Any doubts still here for understanding the piston rings? I hope I have made very clear. Any doubts? No doubts? Okay. Now let's come to a stroke, definition of stroke. So all the components are complete. Now let's come to the stroke. What is a stroke? Stroke is basically a motion of the piston from one of the dead center to other dead center. Okay, I'm not saying top dead center to bottom dead center. Either it can be top to bottom or bottom to top. So from one dead center to the other dead center. Okay, motion of from one dead center to another dead center. Now some question should be asked that why we are calling it as a dead center. This should have been your doubt. This should have been your doubt, right? Why we are calling it as a dead center? Anyone can tell me? Okay, you didn't ask any question, but anyone knows why we call it as a dead center? Why not we say top center and bottom center? Anyone can tell?
Movement ends over that position.
Okay, but what does it mean then? Moment ends. Top end center we should have then said, or bottom end center. Why we call it dead? Yes. Piston remains stationary. Correct. That means the velocity is zero at that instant. Okay. Piston becomes stationary. That means the velocity of that at that position, the piston achieves zero velocity, and acceleration has changed its magnitude. Okay. Direction of motion because of the acceleration, right? So acceleration changed its direction. Okay. Whereas the velocity became zero at that position. Okay. So dead center because velocity is equal to zero at that instant, and it changes direction because acceleration is still there. Now we'll come to the clearance volume and some clearance ratio definition. Okay. Although I gave a glimpse of what is clearance volume and all, but in technical terms, let us understand. Okay. So again, I have a piston cylinder arrangement. Okay. This is your piston. This is your connecting rod, crank rod, and your crankshaft. Okay. So what is happening? There is some volume here. Suppose this was your top dead center. Okay. And this is some gap kept. Okay. This is some gap kept. And this is your bottom dead center. Okay. So what is the complete length of the cylinder? Complete length of the cylinder is this much. L of cylinder. But what is the swept length? That is from top dead center to bottom dead center. That is your L swept. How much the piston has moved from top to bottom. Okay. That is your swept length. Okay. And the volume covered during the swept length is called as stroke volume or swept volume. Okay. The volume associated with this is volume swept, and the volume associated here is nothing but your that is your clearance volume, some volume you are keeping. V clearance volume. Okay. So the total cylinder volume is nothing but V of cylinder is, oh sorry, V of cylinder, or you can say total V of clearance plus V of swept. Okay, we can say that total cylinder volume is clearance volume plus swept volume. So from here we come up with a term that is called as clearance ratio. I think this was one of the person's doubt. What is clearance ratio? I told you we'll come to this. So clearance ratio is nothing but clearance volume to that of swept volume, VC by S. VC by Vs. And what is your clearance volume? That is your, if I say this is my this is my L clearance, or you can say, uh, okay, so this was L swept L. I'll not write here. So if I say this L cylinder is L dash and L swept is L, okay? L swept is L and L dash is your L cylinder, if I notate that. So clearance volume will be from cylinder formula. Volume of a cylinder is nothing but pi by 4 d square. So this is the diameter because it's a cylinder, so I can write this is the diameter. I'll use some another color. This is your basically bore. We also call this as a bore. If a term comes like bore, that means a diameter. Pi by 4 d square, and the length of this is complete L dash minus L. L dash minus L. Complete cylinder length minus swept length. Okay. To that of what is swept volume? That will be pi by 4 d square L. Pi by 4 d square L. Okay. Any doubts? This is your clearance ratio. Clearance ratio. Okay. And there is also a square ratio. Square ratio or over square ratio. So square ratio, use another color. Square ratio is associated as L, that is your swept length to that of bore, L by D. Or we can say over square ratio. That is also notated as L by D. But what is the difference here? That this L by D is generally 1, and for over square ratio, this L by D is generally 1.5. Okay. This you can have a remember. Okay. So some books use square ratio, some books use over square ratio. So this is a textbook references. Okay. And what you see that your crank rod is moving in a circular motion, correct? This was moving in a circular motion. This, as the piston moves down, crank rod moves in a circular motion. So that means when it is at the top dead center, then it will be at the peak position, that is TDC. So when it is TDC, the whole connecting rod and the length, connecting rod and crank rod are straight. When it has come to BDC, then your position will be like this. Okay. All right. So at TDC, and this crank rod is moving with the angular velocity, that is omega. So what we can say that the length of your swept length is nothing but, if the radius is r, if this radius is r, you can say that the length, this 2r basically is equal to length. Length is equal to 2r. The swept length is equal to twice the r. So we have converted the Cartesian coordinates into a polar coordinate. Okay. So length is equal to twice of r of crank. Let me write crank. Any doubts in understanding this thing? So length of your swept length is nothing but equal to your twice of radius of the crank. Any doubts? No doubts. Okay. So we have basically 4 strokes. We have suction stroke, where it moves from top dead center to bottom dead center, top to bottom. Then we have compression stroke, where it moves from bottom dead center to top dead center. Then we have expansion stroke, or power stroke, where it moves from, does it move during the expansion or power stroke? Top to bottom, correct? Okay, top to bottom, and energy stored in the flywheel. And final is your exhaust stroke, where it moves from bottom to top. Okay, bottom to. So these are your 4 strokes which is happening. So that means you can say that a 4 stroke, when the 4 strokes are happening, this is creating 1 stroke and then second stroke. So 2 revolutions are happening. So one from top to bottom, first stroke, bottom to top, second stroke. So 1 revolution completed. Then again top to bottom and bottom to top, second revolution completed. Okay. Does it make sense? So 4 stroke means 2 revolutions are happening. That means 2 revolutions are happening. So this is nothing but your 1 complete cycle. 4 stroke means 2 revolutions, and that means 1 complete cycle. That is from suction to exhaust. Okay, suction to exhaust. So if I say, let's take an example. If I say that my N is 2400 RPM. Okay. So if it's an RPM, in 1 minute, there are 2400 revolutions happening. What if I say in RPS, I'll divide by 60. So that will be 2400 divided by 60, because 1 minute has 60 seconds. So it will be 40 RPS, 40 revolutions in 1 second. 40 revolutions. If I'm saying 40 revolutions, so how many cycles have passed? 2 revolutions make 1 cycle. So 40 revolutions will make how many cycles? Please, anyone? 40 revolutions will make how many cycles? Biswajit, how many cycles?
20 cycle.
20 cycles, correct, Amos, right? 20 cycles. Because 2 revolutions make 1 cycle, so 40 revolutions will make 20 cycles, correct? 20 cycles. Okay, so that is 20 cycles each. In each cycle, each stroke is coming 1 time. In each cycle, each stroke, suction stroke, compression, expansion, exhaust, each stroke comes 1 time in complete 1 cycle. That means 20 power strokes or 20 suction strokes or 20 compression stroke or 20 exhaust strokes will be in each cycle, in all these 20 cycles. Okay, you understand that? Okay, now let's come to one last point. I'll take 2 minutes of yours. So we have swept volume, but this is a theoretical relation. Theoretical swept volume is nothing but pi by 4 d square into length, that is swept length. Okay, if I have 1 cylinder, when we say that our car is 4 cylinder, 3 cylinder, 3 cylinder engine, 4 cylinder engine, 8 cylinder engine, then I'll write multiply with n for number of cylinders. So that will be your total volume of the engine. When you see now, it is 1.2 cc engine, cubic centimeter. Okay, what kind of engine is this? So that means they are asking the total volume of all the cylinders they are comparing. Okay, so it means that not n, I'll denote by k. So that means this k is number of cylinder, and this complete, my friend, is your total volume in meter cube of that engine. Total volume in meter cube of the engine. Okay, so this is your theoretical concept. Okay, if I say this is a swept volume, if I say rate of swept volume, so that means n by 60 in revolutions per second. If I say, so it will be multiplied with n by 60. Okay, n by 60. So this will be your suction volume flow rate. This will be your suction volume flow rate. And this will be in your meter cube, because this was in meter cube, and divided by 60, that means meter cube per second. Okay. So if I'm saying that in general context, if it is written like this, that it will be whole divided by 2 for a 4-stroke, depending on the number of revolutions. If one engine has a 4-stroke engine, so that means 2 revolutions are happening, because we are multiplying with the number of revolutions. If it's a 4-stroke engine, then we will divide by the 2. So 2 or n, depending on the number of strokes for different strokes. Okay. So then only you can say that it's a suction volume flow rate in meter cube per second. Any doubts still here? Please ask. Yes, Keswaji.
ঠিক আছে স্যার প্রবলেম হবে না
Okay. All right. CC full form. Hello.
Sir, your voice is not able. Your mic is switch is off condition. Your video is visible, your audio is not clearly, because your mic switch is off condition in the display of the computer.
Am I audible now? Hello.
Okay, yes, sir.
So far nothing could be here. Whatever I speak in last few minutes. You couldn't hear any of this thing? Can you please confirm me?
So it was audible.
It was audible. Okay. Content. Okay. Yeah, someone was asking, CC full form is your cubic capacity of the, or cubic centimeters. Yeah, that all of the cylinder. Okay. So let's stop here, and in the next lecture we'll start with the Otto cycle eventually. That is your petrol cycle. And all these videos, once again, let me tell that all these videos will be available to you along with your PDF notes. NPTEL team will send a mail to all of you where the links of the PDFs and everything will be there. And all these videos are recorded and uploaded on my YouTube channel. So name of my YouTube channel, if you want to see just now, I'll post it soon. YouTube channel name is NPTEL with Varnit. Okay. So in every video description, you will see all the links for the Google Drive. All the notes will be there. Okay. And I'll post this video on my channel as well, recording of this video. Any further doubts? You can end the session. Otherwise, all right. So I'll see you next Tuesday. Every Tuesday, we're having once a week tutorial, 6 to 8 p.m. And till then, I hope that everyone completes the assignments and everything. Okay, bye.